This is Chapter 1, Graphs, Functions, and Models. Okay, models means word problems, so we will see word problems in this chapter. Okay, Section 1.1, Introduction to Graphing. Okay, now, part of this you've probably seen before in the graphing. Now, you are allowed to use your graphing calculators, the TI-83, TI-84. You are allowed to use those. So, Part 1 here, the rectangular coordinate system. This is something you should have seen before, the rectangular coordinate system. So, we set up the rectangular coordinate system by drawing a horizontal number line called the x-axis and a vertical number line called the y-axis. The two axes together are called the coordinate axes. We let 0 correspond to the same place on both axes. By convention, to the right and up for positive. Where the two axes meet is called the origin. Kind of the origin is where we start measuring for everything. So we start measuring where the two axes meet. So the next slide shows a picture of the rectangular coordinate system. Now hopefully again this is something you've seen before. Okay, here's my x-axis, here's my y-axis. They are perpendicular to each other, and I don't know if you can read off the numbers, but that's 1, 2, 3, 4, 5, and so on. Negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, negative 3, and so on. The arrowheads point in the positive or increasing direction. So to the right is positive, up is positive. You know, just like on a thermometer for the vertical y-axis. So this thing is called the rectangular coordinate system or rectangular plane. It's also called the XY coordinate system or XY plane. Now, a plane is any flat surface, like your paper, this screen, the chalkboard. Any flat surface is a plane. Number 3, the Cartesian coordinate system or the Cartesian plane. This is Honor of René Descartes. Now, he's not the one who came up with the idea, but after he wrote it down, people kept remembering it. It's also called two-dimensional real space. 2 dimensions because you have 2 axes. You can go left, right, up, down. It's also called two-dimensional Euclidean space. This is Euclid as in geometry. It's also called the plane. Remember, a plane is any flat surface. The plane is you put the x and y axes on it. Okay, this is a smaller picture of the same thing. A point on the plane is a location. Its location is given by an ordered pair xy called the coordinates of the plane. It's always xy, it's always in parentheses. You must enclose an ordered pair in parentheses. If you've not enclosed it in parentheses, it's wrong. Okay, x is always first, then y. It's alphabetical order. If for some reason you see a plane that's not using x and y to label the coordinate axes, it could still be called the plane, but if it doesn't use x and y, the ordered pairs are in alphabetical order. Like if you have p and q, p is first, then q. If you have a and b, a is first, then b. It's alphabetical order. Number 2, x is called the first coordinate, x coordinate abscissa. It tells you how far to move left or right from the origin. Positive is to the right, negative to the left. So remember, you start at the origin and then move left or right. Always start at the origin. Remember, the origin is where the two axes meet. Y is called the second coordinate, y coordinate, ordinate. It tells you how far to move up or down after having gone left or right. Positive is up, negative is down. In the picture at the left, we have plotted the following points. So let's see, my red point, A, is negative 4, 5. So from the origin, go left 4, 1, 2, 3, 4, then up 5. 1, 2, 3, 4, 5. Yep. B is the point 0, 3, so don't move left or right, but go up 3. 1, 2, 3. Negative 2, 0 for the green point. Move left 2, 1, 2, but don't go up or down. Okay, hopefully you can also tell the colors. Red, blue, green. On the test in D2L, the graphs are going to be in different colors, and it's multiple choice in D2L. Now, in my math lab, sometimes it's multiple choice, and sometimes you actually have to draw the graphs. So, the coordinate axes divide the plane into 4 regions called quadrants. The quadrants are numbered using uppercase Roman numerals. Quadrant 1 is in the upper right-hand corner, so up here. And then the others are numbered going counterclockwise. So, 1, 2, 3, 4. So again, start in the top right, and then go counterclockwise. 1, 2, 3, 4. The axes are the boundaries of the quadrants, are not considered to be part of any quadrant. The origin has coordinates 0, 0, and is on both the x and y axes. It is the only point that lies on both coordinate axes. Let's try some examples. The examples we're going to look at is kind of like graphing without graphing. So determine whether each point lies in or on quadrant 1, quadrant 2, quadrant 3, quadrant 4, x-axis, y-axis, or none of the above. Okay, so this is multiple choice. Quadrant 1, 2, 3, or 4, x-axis, y-axis, or none of the above. Here are our points. And remember, the quadrants, you start at the top right and then go counterclockwise. So if I'm looking at the point negative 4, 6, so from the origin, it's like imagine with the origin being here, left 4, up 6. We're in quadrant 2. The point negative 5, 0. So again, start at the origin, move left 5. We've stayed on the x-axis. 0, negative 45. Again, start at the origin, go down 45. You're on the y-axis. The point 5, negative 9. Again, start at the origin, go right 5, down 9. You're in quadrant 4. Negative 6, negative 3. Left 6, down 3. You're in quadrant 3. And 1134, right 1, right 11, up 34. You're in quadrant 1. Again, remember the quadrants, start at the top right, then go counterclockwise. 1, 2, 3, 4. Okay, now for trig classes, it's important that you know the algebra sign of each coordinate in each of the quadrants. For us in algebra, we really don't care about it. Equations in two variables. Now back in section R.5, we looked at equations in one variable. Now remember, except for those two weird cases that had no solution in all real numbers, whenever we solved an equation in one variable, we just got one answer. So it's either one answer, no answer, or every number was going to work. Let's see what happens when we have two variables. So definition, an equation in two variables is an equation that has two unknowns in it. Sometimes we will name the variables by saying an equation in x and y. Again, I like the equations in x and y because we have that xy plane. Definition, a solution to an equation in two variables is an ordered pair that when substituted into the equation makes the equation true. So you have to give me an ordered pair, which means an x value and a y value, and you put them in parentheses. Remember, an ordered pair must be put in parentheses. That's what makes it an ordered pair. So, for some examples. For each equation, determine whether or not the given ordered pairs are or are not solutions to the equation. So for each part, you're going to write down solution or not solution or something like that. So here's my equation, 3x minus 2y equals 12, and here are the parts to the problem. So I need an answer for each of A, B, C, and D. So for part A, 4, 0, x is 4 and y is 0. So in this equation, let x be 4 and y be 0 and see what happens. So I have 3 times 4 minus 2 times 0 is that 12. Okay, 3 times 4 is 12, 2 times 0 is 0. So 12 minus 0 is that 12? I believe it is. So 4, 0 is a solution. Let's try part B. X is 2 and y is negative 3. So in the equation, let x be 2 and y be negative 3. So 3 times 2 minus 2 times negative 3, does that equal 12? I got 6, and minus times minus is plus. I got 6 plus 6, is that 12? Yes, it is, isn't it? So 2, negative 3 is also a solution. Okay, now, if we were just dealing with an equation one variable, if I found two values that worked, that would say all real numbers work. Let's see if something like that happens here. For part C, x is negative 2 and y is 3. So let x be negative 2 and y be 3 up here. So 3 times negative 2 minus 2 times 3, is that 12? This is negative 6 minus 6. I don't think it's going to work. So negative 12 equal 12? No. So negative 2, 3 is not a solution. Notice this could not have happened if there were just one variable. So something different is happening when I have two variables. Let's now try part D. So x is 8, y is, that should say y is 4, shouldn't it? This right here should be 6. Made a typo here. So y should be 6 like it says. So x is 8, y is 6. So 3 times 8 minus 2 times 6 is that 12? 24 minus 12? Well, yes, that works, doesn't it? So 8, 6 is a solution. Let's try another one. I have 3x equals 12. Okay, notice there is no y. Okay, here are my candidates for solutions. Since there is no y, we don't substitute a value for y anywhere. Just plug in the value for x. So x is 4, y is 0. And again, there is no y in the equation, so that means the value of y does not matter. Only the value of x is used. So put x is 4. 3 times 4 equals 12? Yeah. And remember, don't put the 0 anywhere because there is no y. So 4, 0 is a solution. For part B, x is 0 and y is 4. So you plug in x is 0 and don't put the 4 anywhere because, again, there is no y in the equation. So 3 times 0 equals 12? I don't think so. So 0, 4 is not going to be a solution. Okay, 4, negative 13. Again, x is 4 and y is negative 13. But remember, negative 13 doesn't go anywhere because there is no y in the equation. So just let x be 4. 3 times 4 equals 12? I bet it does. So 4, negative 13 is the solution. Notice, anytime x is 4, it's going to work, no matter what y is. And lastly, 2, 11. X is 2, y is 11. The 11 doesn't go anywhere. Replace the x with 2. 3 times 2 equals 12. I doubt it. 6 equals 12. I don't think so. So it's not a solution. Okay, so you just plug it in and see if it works. Okay, let's look at graphing equations now. Again, you are allowed to use your graphing calculator. And I'll go ahead and take mine out and show you how to graph on it. Now remember, in D2L, the test in D2L, all the graphings are multiple choice. In my math lab, they could be multiple choice, or they could also make you draw it by hand. So definition, a graph of an equation is a picture representation of all of the solutions to the equation. Remember, we got more than one answer. We didn't get all real numbers as an answer, but we got more than one answer. So it's not possible to actually make a list of all the solutions to an equation in 2 variables. So what we do is we draw a picture instead, and that picture is called the graph of the equation. So we want to find efficient ways of graphing equations without resorting to using a graphing calculator. So this is kind of like your backup plan if your graphing calculator batteries die. You know, you can't just run out to the bookstore and get some batteries while you're taking the final exam or something. So the techniques that we developed turn out to be how a graphing calculator is graphing an equation. So we're going to do the exact same thing your graphing calculator does, it's just that your graphing calculator does it a lot faster. So, intercepts. Okay, intercepts. Got a 2-part definition. Number 1, an x-intercept is a point where a graph crosses or touches the x-axis. So, x-intercept, cross or touch the x-axis. Number 2, a y-intercept is a point where a graph crosses or touches the y-axis. Later on in Chapter 4, for certain types of graph, we will be able to distinguish between cross and touch. There actually is a difference for certain types of graphs that we can tell. Some facts. Number 1, the y-coordinate of an x-intercept is 0. Remember, the x-intercept, you're crossing the x-axis, so you did not move up or down. The x-coordinate is usually noted by the lowercase letter a. As a point, an x-intercept is noted by a, 0. Number 2, the x-coordinate of a y-intercept is 0. Remember, you're crossing the y-axis, so you didn't move left or right. The y-coordinate is usually denoted by the lowercase letter b. As a point, a y-intercept is noted by 0, b. Now, some of you may have been told back in high school that you should always find the intercepts. Well, if the intercepts don't exist, then there's nothing to find. Now, it's true if the intercepts do exist, it does help you to graph. Now, in general, to find any intercept, let the other variables be 0. No matter how many variables there are, to find a particular intercept, let all the other variables be 0. So here's a picture. Here's my x-intercept, I'm crossing the x-axis. Here's my y-intercept, I'm crossing the y-axis. If I had to give an x value, to me that looks like 3.5. So I'd have 3.5, 0 as a point. For y, that also looks like 3.5. So I'd have 0, 3.5 as a point. Okay, now for points that are kind of like this, be reasonable. Like calling this 3.5 seem reasonable. To call it 3.9, that's not quite reasonable. 3.9 would have to be a lot closer to 4. So this is how you find them when the picture is drawn. You just find where you're crossing or touching the axes. How do you do it algebraically? So the method for finding intercepts. To find the x-intercepts, let y equal 0 and solve for x. You're actually finding the x-coordinates of the x-intercepts. The y-coordinates are 0. So notice you're doing a substitution and solving an equation. To find the y-intercepts, okay, kind of do the opposite. Let x equal 0 and solve for y. You're actually finding the y-coordinates of the y-intercepts. The x-coordinates are 0. So for each of the following, we're going to find in part A the x-intercepts, part B the y-intercepts. We will simplify your answers, do not use mixed and reducibles in your answers, and express your answers as ordered pairs. Let's try some. So I've got 2x minus 6y equals 12. Now later on we're going to discover that if you were to graph this, it's a line, and 2 points are enough to draw the line. So finding the intercepts will let you draw the line. So the x-intercepts. Remember, to find the x-intercepts, let y equal 0 and solve for x. So in this equation, let y be 0. So I'll have 2x minus 6 times 0 equal 12. Okay, 6 times 0 is 0, so this part just goes away. So you got 2x equals 12, or 2x minus 0 equals 12. Again, 2x equals 12. Divide by 2. I get x is 6. As an ordered pair, 6, 0. And again, you do need the parentheses around the 6, 0. Okay, for the y-intercepts. Okay, you're going to let x equal 0 and solve for y. So go back to the equation and let x equal 0. So I have 2 times 0 minus 6 times y equals 12. Okay, 2 times 0 is 0. So 0 minus 6y is 12. So you get negative 6y is equal to 12. Divide by negative 6, and you get y is negative 2. As a point, 0, negative 2. Again, I told you this was a line. So if you were drawing this graph, you would draw the line that passes through those 2 points. Okay, 2 points will draw the graph for a line. Let's try another one. I've got y equals x squared minus 2x minus 3. Okay, now again, you're finding the intercepts. So for part A, the x-intercepts, remember, let y equal 0 and solve for x. So in this equation, let y be 0. So I've got 0 equals x squared minus 2x minus 3. Okay, I've got the x squared, so that means I have to factor this guy. Multiply to be negative 3, add up to be negative 2. Okay, to be negative 3, it's got to be 1 and 3. The bigger gets the sign in the middle, minus. So x minus 3, x plus 1. Okay, then set h factor equal to 0. Remember, equation solving was done back in section R.5. So I've got x minus 3 equals 0 or x plus 1 equals 0. Okay, add 3, subtract 1. So I've got x is 3 or negative 1. Now please, don't put 3 comma negative 1. It's 2 separate points. 3, 0, negative 1, 0. So 2 separate points here when you get 2 values for x. So 3, 0, and negative 1, 0. Those are your x-intercepts. Okay, for the y-intercept, okay, let x be 0. So back up here in this equation, let x equal 0 and solve for y. So y is going to be 0 squared minus 2 times 0 minus 3. Okay, 0 squared is 0, 2 times 0 is 0. I end up with y equals negative 3. As an ordered pair, 0, negative 3. Okay, let's actually move on to graphing. So actual graphing. Now again, you are allowed to use your graphing calculator. So we will make a table of values until we see a nice shape. All of our equations will have nice shapes. So when you plot your points from your table of values, if you find it going all over the place, something is wrong. Now nice shapes would be like a line, a circle, or what's called a parabola, which we will see in the examples. So here's our first one. So graph each of the following equations. Okay, so we're going to give you an equation. Here's our first one. Y equals 3x minus 2. Okay. If I actually take out the calculator, I guess I got to turn it on. Okay, here's your y equal. Notice in order to graph an equation, it must say y equal. So press your y equal. I want to type in 3x minus 2. 3, here's your x, minus 2, and then just say graph. I get this line. Okay, let's see what we do by hand. So our solution. Okay, the shape is a line. Okay, this is how you know it's a line. These are the conditions for an equation to be a line. So an equation graphs as a line when it meets the following conditions. Number 1, no variable appears in the denominator. Number 2, all variables have exponents of 1. See, you don't see the exponent, so it's 1. Number 3, no 2 variables multiply each other. Okay, 2 variables multiply each other like xy or 2xy. That's called a cross product. So no cross product terms. And the fourth condition, no variable is part of a special operation like absolute value, square root, and so on. So it's kind of like, it's a nice looking equation. So these are the conditions that are needed for a line. Remember, 2 points are enough to draw a line. So since we know it is a line, 2 points are enough to graph it. So you don't need to sit there and plot all day long. The equation is solved for y because it says y equals. If it said x equal, we would say it's solved for x. So since it says y equal, we pick x. You can pick any values for x you like. Any. You have to pick easy ones because remember, you're looking for points that are on the line. So you pick x and the equation will give y. So I'm going to pick a nice easy value for x. I'm going to pick 0. So if x is 0, I have 3 times 0 minus 2. which is 0 minus 2, I get negative 2. So I plot the point 0, negative 2, which is right here, my little blue dot there. So again, you can pick any value for x you like. Pick something incredibly easy. Another easy value for x, remember you need at least 2 points, so another really easy value for x, for me, is 1. So if I let x be 1, I'll have 3 times 1 minus 2, which is 3 minus 2, I get 1. Okay, it's just a coincidence that x and y are the same. So I'm plotting the point 1, 1. There's my dot. Now again, this is actually enough to draw the line. I like to plot a third point as a check. When it says y equals or x equals, I will plot a third point. I like to pick something negative. An easy negative number is negative 1. So I have 3 times negative 1 minus 2. I get negative 3 minus 2, I get negative 5. So I'm plotting the point negative 1, negative 5 down here. Okay, does it look like those 3 points are lining up? Okay, now when you draw the line, don't just connect these 2 dots. Draw the line that goes through the 2 points, through the points. Okay? So there's my line. Now comparing this to what my calculator drew, do they look the same? Okay. Now again, remember, this is supposed to be a picture of all the numbers, or excuse me, all the ordered pairs that make this equation true. So this looks like an easy point. It looks like the point 2, and what is that, 1, 2, 3, 4? 2, 4. So if I plug in x is 2, where'd I go? If I plug in x is 2, 3 times 2 is 6, 6 minus 2 is 4, yeah. So remember, this is a picture of all the ordered pairs that make this equation true. Let's try another one. I've got 2x minus 3 equals 6. Okay, this is also a line. It meets the conditions. I have no variables in the denominator. My variables have exponents of 1. I don't have any cross products, and I don't have any special operations. Now, this one doesn't say y equals, so I can't give it to the calculator, because, again, going back to the calculator, it can, let me clear that out. It only can handle y equals. Now, some of you may have been told in high school that you always should solve the equation for y. No, don't do that. If I solve the equation for y, I've got fractions, and I don't want to plot fractions. I could hurt myself. So, when both variables are on the same side of the equation, I like to use the intercepts. Remember, an x-intercept and y-intercept, that's enough to draw the graph. So I'm going to find the x-intercepts and the y-intercepts. So for the x-intercept, let y be 0. Okay, 3 times 0 goes away. I have 2x is 6. Divide by 2, I get x is 3. And there is my x-intercept, 3, 0. Okay, let's do the y-intercept. Remember, let x be 0. So let x be 0. 2 times 0 minus 3y equals 6. 2 times 0 goes away. Negative 3y equals 6. Divide by negative 3. Y is negative 2. Okay, now, the downside of just doing the intercepts is I don't really have a third point as a check. Now, when you draw the line, don't just connect the 2 dots. Draw the entire line that passes through the 2 points. Now again, this is a picture of all the solutions to that equation. A good point that looks like it's here is, what is that, 1, 2, 3, 4, 5, 6. That looks like 6, 2. So if I plug in 6, 2, 2 times 6 is 12. 3 times 2 is 6. 12 minus 6 is 6. Okay, so again, this is a picture of all the ordered pairs that will work. Because if I look at this point, it looks like a really good one. Looks like I get negative 6 and negative 6. Okay? So negative 6 times 2 is negative 12. Negative 6 times 3 is 18. Negative 12 plus 18 is, in fact, 6. Let's try another one. Y equals absolute value of x. Okay, now, absolute values have the shape of a V. Okay, so we plot enough points to see the shape of a V. Now, there is an absolute value key on your calculator, but it's so well hidden it's not worth trying to find. So let's just plot some points. So again, absolute values, they look like V's. So we want to plot enough points to see a V. So again, I make my table of values. Remember, you're free to pick x because it says y equal. Pick easy values for x. I pick 0. Absolute value of 0 is 0. So I have a purple dot right there. You probably can't see it, but there's a purple dot at 0, 0. Another easy value for x, I don't know, 1. Absolute value of 1 is 1. So I've got 1, 1. Now please, don't just plot 2 points and say, oh, it's a line. Remember, anytime you plot 2 points, it's a line. I'm supposed to get a v. Now with absolute values, again, take some negative values for x. Something easy, negative 1. Absolute value of negative 1 is also 1. Okay, 1, negative 1. Do you kind of see a v taking shape now? I got bold and daring. I chose 3. Absolute value of 3 is 3. So I'm out here at 3, 3. Let's go ahead and do the negative 3. Absolute value of negative 3 is also 3. I believe I see a v taking shape. So again, all absolute values will have a V somewhere. The characteristic of a V is this sharp point right here. And it is sharp, it's not smooth and rounded. Let's try another one. Before I got y equals x squared. Okay, this one does say y equals. This shape is a parabola. So we're about to see what a parabola is. Let's go to our y equals. Okay, clear that out. And let's say x, and then here's your squared key. And then just say graph. Okay, that's a parabola, this kind of U-looking shape. Now, the calculator did make a table of values. If you want to see it, notice this thing in orange. Now, if you're using the TI-84, I think it's in blue. So do the second and then table. There's your table of values. There's the x values, there's the y values. So notice I got -3, 9, -2, 4. Here's your interesting thing. Why is it showing me all these zeros? Evidently, sometime in the past, I set my mode to 5. So set it to float. Let's quit. And now let's do the table again. All those distracting zeros are gone. Okay. So notice it tells me the x value, and then there's my x value, and then here are the y values. But if we're doing it by hand, so let's quit that. Let's go back by hand. Okay, so that parabola is actually again a U shape. So the shape is called a parabola. So I picked x, equation gives y. Again, let's try some really super easy values. 0. 0 squared is 0. So there's my green dot at 0, 0. Here, you're probably saying, I think I'd always pick 0, 1, -1. Yeah, they're good values. If x is 1, 1 squared is 1. Again, don't just say it's a line, or anytime you plot 2 points, you can get a line. If x is -1. Okay, -1 squared is also 1. That was kind of like our v thing. Let's see what happens if I go to the 2's. 2 squared is 4, so I'm way up here. -2 for x. Well, -2 squared is also 4, so I'm up here. Okay, if I do the 3's, I'm up to 9. I'm probably going to be off my graph. So now, as best you can, draw a nice, smooth curve. Okay, the parabola is rounded down here. Remember, the V was a sharp point. You have to tell them apart. Okay, now again, for my math lab, when you start to draw it, you would have to actually grab the little icon that looks like a parabola. So you have to know in advance that you're graphing a parabola when you do this. Now, how do we know it's a parabola? One of the variables is squared. Okay, if one of the variables is squared, that's a parabola. Number 5, I have x equals y squared. Okay, one of the variables is squared. This is a parabola. Okay. Now, this one says x equal. Your calculator cannot do x equal. Okay, so please don't use your calculator for x equal. Make a table of values. This is going to be a parabola on its side. Okay, how we're going to be able to tell this? We're going to make a table of values. Okay, so the equation is solved for x, so it says x equal. So we will pick y, and the equation will give x. You still plot xy. So remember, we're going to pick the y, equation will give x. So our table of values will be filled in from right to left. Okay? So again, we're going this way. I'm going to pick 0 for y. 0 squared is 0. So I plot 0, 0. Remember, this column is the x, that's the y. So 0, 0. Okay? So far it looks like the other parabola. I have another easy value for y. I don't know. -1. I chose the negative first. Okay, -1 squared gives me 1. So I plot 1, -1. 1, -1. Okay, let's go ahead and pick the positive y. 1 squared is 1, so I'm looking at 1, 1. Do you kind of see the parabola on its side now? Let's pick the 2's. 2 for y, 2 squared is 4, so I'm plotting 4, 2. Remember, this is the x column, 4, 2, 4, 2. And if y is -2, -2 squared is also 4. And now the parabola on its side looks a little more obvious. So draw the parabola to the points. Again, don't just play connect the dots. Okay? Don't be afraid to go beyond it. You're not going to hurt it. Now, oddly enough, in my math lab, you have to plot at least 3 points for a parabola. Okay? And once you've got those 3 points, I think it's actually 2, but one of them has to be special. And once you've plotted them, the software itself, my math lab will actually draw the graph for you. Now remember, in D2L, the graphs are multiple choice. So all you have to do is be able to recognize them. Hey, let's try one more. I have y equals 2/3 x minus 2. Now, this is also a line. Okay, this is also a line. The reason I went back to drawing a line is I want to show you some of the flaws of always using 0, 1, and -1. So this is another line. All we need is 2 points, but because it says y equals, I'll go ahead and plot a third one. So I'm still going to pick 0. 0 is always a good point. So if x is 0, Okay, y is going to be 2/3 times 0 minus 2. Okay, 2/3 times 0 is 0. So 0 minus 2, I get negative 2. 0, negative 2. I got right there. Now, instead of picking 1 for x, I'm going to pick whatever the denominator is. That way it'll cancel. So instead of 1, I'm going to pick 3. If this were 6, I'd pick 6. Whatever the denominator is, that's what I'm picking. So if x is 3, okay, the 2/3 times 3, the 3's cancel. You're left with 2 minus 2, which is 0. Oh, how convenient. Now notice, if you're in a rush, you can now draw it. Okay, for my third point, instead of picking negative 1, I'm going to pick negative 3. So I always pick the denominator and negative denominator. So if x is negative 3. Okay, again, the 3's cancel, but remember, the minus sign survives here. So you'll have negative 2 minus 2, which is negative 4. So negative 3, negative 4, look like they're lining up. Yep. Now, since this was a y equal, again, my calculator could have done it. So let's turn it back on. Let's go to our y equal. Let's clear that guy out. So I've got 2/3 x minus 2. And let's just say graph. Does this graph look like this one? And again, if you want to see your table of values, just do second graph. And here's our table of values. Notice we picked a negative 3 and got negative 4. Hey, so did they. X is negative 3 and y is negative 4. They picked x to be 3 and got 0. So did we. 3, 0. How about that? Okay, let's move on to bigger and better things. Distance and midpoint formulas. Okay, they're just formulas. They're always presented together, but they're just formulas you have to use. So let's start off with the distance formula. The distance formula gives, as its name implies, the distance between 2 points, or, if you remember your days of high school geometry, the length of the line segment joining the 2 points. Remember, the shortest distance between any 2 points is a straight line. So this is talking line segments, not just lines. So it really is just connecting 2 dots. So the midpoint formula gives the point that is in the middle of a line segment, hence the name midpoint. And notice, it is a point. That means it belongs in parentheses, ordered pair. Points are always in parentheses. They're ordered pairs. So the two formulas are always presented together. Always, always, always. The distance formula. So we let P1 with coordinates x1, y1 and P2 with coordinates x2, y2 be 2 points on the plane. Okay, the little subscripts just say that these aren't really variables. They're going to be values made known to you. Then the distance between P1 and P2 is given by, okay, d for distance, it's equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's the difference in the x's squared plus the difference in the y squared, and then take the square root. And yes, you should simplify the square roots. Okay, where does the formula come from? Okay, now again, I'm not going to really hold you responsible for deriving it, but you do need to know where it comes from in case someone ever asks you, like, hey, where did the distance formula come from? You can say, oh, it came from this. So here's a picture. The picture below shows the setup for the distance formula. Okay, we're going to draw 2 extra lines so you can see where it comes from. Okay, so this is the point x1, y1. Okay, the ones really should be closer to the variables, but they just seem to have migrated apart from each other. And this is the point x2, y2. This is the distance between them, that straight line segment. I'm going to draw a horizontal line and a vertical line. So I've got a right triangle. Okay, so from this right triangle, you can now see you're looking at the hypotenuse of a right triangle. So if someone asks you, where did the distance formula come from? It comes from the Pythagorean theorem. Okay, in fact, some books will say, use the Pythagorean theorem to find the distance between these 2 points. Okay, you now know you're looking for the hypotenuse of a right triangle. Remember, a squared plus b squared is c squared. Let's try some examples. Find the exact distance. That means leave the square root between each pair of points. Simplify your answers. So if you've got the square root of 25, you'd write 5. Do not approximate. Let's try some. Here's our first one. I got 5, negative 7, negative 3, negative 2. Okay, now, they don't know who's first or second. So I'm going to call x1, y1, 5, negative 7, and x2, y2 will be negative 3, negative 2. Again, they don't know, they don't care. So the distance formula is square root of x2, square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, fill in the values and just plug away. So I'm going to have negative 3 minus 5 squared plus negative 2 minus negative 7 squared. Okay, now just do the arithmetic. Negative 3 minus 5 is negative 8, so negative 8 squared. Negative 2 minus negative 7, okay, minus minus is plus, so I get to 5. It's going to be 64 plus 25. I get the square root of 89. Okay, The square root of 89 is simplified. Okay, that's the exact distance. If you want to get an approximation, you've got to take out your calculator. So notice it's just some basic arithmetic. Let's try another one. I've got the points -4, 7 and 8, 2. Again, they don't know who's first or second, so I'll let x1, y1 be -4, 7, and my x2, y2 will be 8, 2. Now, those of you with the eagle eye, you may have noticed I got a typo here, right? There's supposed to be a space after the comma. So if I plug into the distance formula, which remember that is our distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to have square root of 8 minus -4 squared plus 2 minus 7 squared. Okay, 8 minus -4 is 12. 2 minus 7 is -25. Excuse me, -5. I've squared, haven't I? 12 squared is 144. -5 squared is 25. That gives me square root of 169, which is 13. If you left it at square root of 169, that would not be correct because it does simplify to be 13. Okay, it's kind of hard to make this interesting. You're just plugging in numbers. Let's move on to the midpoint formula. So the midpoint formula, remember, it gives you the coordinates of the middle of a line segment. So again, we let P1 with coordinates x1, y1, and P2 with coordinates x2, y2 be 2 points on the plane. Then the midpoint, the line segment joining P1 and P2 is given by, okay, again, here's our formula. Okay, I call it capital M as in midpoint. So the x-coordinate is x1 plus x2 over 2, and the y-coordinate is y1 plus y2 over 2. So add up the x's, divide by 2, add up the y's, divide by 2. And again, don't forget parentheses around it. It is a point. Okay, now a picture of the midpoint formula. Okay, so the midpoint is a point again. You must use parentheses. Okay, if you don't, it's wrong. So here's a picture. Okay, here are my P1, P2. Does it look like M is in the middle? Okay, now again, my little subscripts have migrated far away from their variables. That should be x1 plus x2, and that should be y1 plus y2. My subscripts have really migrated away from them. Okay, now to actually prove it, you would use the distance formula to show that this length and this length are equal. Okay, it's just a lot of messy algebra. No one ever does it. Let's try some examples. Okay, number 1. Find the midpoint of the line segment joining the points -5, 6 and 9, -12. Simplify your answers. No mixed numbers and decimals. Okay, now again, they don't know x1, y1, x2, y2, so -5, 6 will be x1, y1. 9, -12 will be x2, y2. You can remember our midpoint formula. Add the x's, divide by 2. Add the y's, divide by 2. So I'm going to have -5 plus 9 over 2, comma, 6 plus -12 over 2. Okay, now let's do the arithmetic. -5 plus 9 is 4. 6 plus -12 is -6. And let's see, 4 over 2 is 2. -6 over 2 is -3. So your midpoint is 2, -3. Okay, to add some variety to this, I mean, otherwise it's just, add some numbers, divide by 2. To add a little variety to this one, let A be the point 5, -5, -9. Let M equal the point -4, 2. It says, suppose that M is the midpoint of the line segment joining the points A and B. Find B. So in this one, you're given the midpoint, one of the endpoints, and you're asked to find the other endpoint. So let's see. P1 will be A, and P2 is going to be B. So notice, I'm looking for P2. So x1, y1 is 5, -9. x2, y2 is B. We are looking for B. Okay, we're looking for B, not the midpoint this time. We're given the midpoint. So we're given x1 plus x2 over 2, y1 plus y2 over 2. We're given that. We're given that that is -4, 2. You're going to have two separate equations to solve. One for x2 and the other one for y2. So it's going to be two separate equations. So looking at the x-coordinates, I'm going to have 5 plus x2 over 2 has to equal -4. So the x-coordinates, 5 plus x2 over 2 has to equal -4. A nice little equation. Clearing of fractions, multiply both sides by 2. So 5 plus x2 equals -8. Subtract 5. x2 is -13. Okay, now let's look at the y-coordinates. So looking at the y-coordinates, negative 9 plus y2 over 2 has to equal 2. So this y-coordinate has to equal this y-coordinate. So negative 9 plus y2 over 2 is 2. Okay, clearing of fractions, multiply both sides by 2. Negative y plus y2 is equal to 4. Add the negative 9. So actually add 9 to both sides. So y2 is going to be 13. Okay, it's just a weird coincidence. So before we found x2, we now have y2. So x2 is negative 13, y2 is 13. So b is negative 13, 13. Remember, you were looking for a point. Okay, let's move on to the last topic of section 1.1. Circles. Definition. A circle is a set of points in a plane that are equidistant from a fixed point in the plane. The fixed point is called the center of the circle. And this distance we're talking about, the distance between the center and any point on the circle is called the radius of the circle. So notice, in order to work with a circle, you need to know the center and the radius. Okay, so you need center and radius. Now some notes on this. Number one, a radius is also any line segment joining the center and a point on the circle. For example, if you're looking at a bicycle wheel, a spoke on the bicycle wheel is considered a radius. The length of that spoke is also a radius. Number two, twice the radius is called the diameter of the circle. A diameter is also a line segment that joins 2 points on the circle while passing through the center of the circle. Okay, now any point that connects 2 points on a circle is called a chord. So it's kind of like the diameter is the longest chord. Now when you're working on the problems, be aware, are you given diameter or are you given radius? Remember, according to the definition, you need center and radius. Remember, the diameter is twice the radius, or another way of looking at it is the radius is half the diameter. Okay, finding the standard form for the equation of a circle. Okay, that's what we're going to call it in this class, the standard form. I believe our book calls it something weird. Standard form is actually its correct name. So let the center of the circle be C with coordinates HK. HK is always the center of the circle. I'm calling it C as in center of the circle. And let the radius be R. R is always the radius with a few exceptions. Sometimes they use the letter A. Then if the point P with coordinates XY is any point in the circle, we have the following picture. Okay, so the center is here. This point P is allowed to move anywhere around on the circle. I want to know what equation does X and Y have to satisfy to stay on this circle. So the center HK will somehow be given to you, just like the radius R will somehow be given to you. So same picture, only smaller. So since the line segment CP, right, CP is a radius, it has length R. Remember, that was our setup. It has radius R. So by the distance formula, the length of the segment CP is, okay, remember, square root of difference in the x's, x minus h squared, plus difference in the y's, y minus k squared. Okay, that's what the distance formula says. Remember, back up here, it's also a radius. So this expression has to equal r. Remember, they're both expressions for the length of CP. It's r because it's a radius. It's this square root thing because of the distance formula. Now, we don't like having the square root in it. So let's just square both sides. So squaring both sides gives us this. X minus h squared plus y minus k squared equals r squared. Notice, everything is squared, and it is x minus h, y minus k, not pluses. This expression right here, the x minus h squared plus y minus k squared, that is called the standard form of the equation of the circle with center hk and radius r. Notice, it's x minus h squared plus y minus k squared equals r squared. That is the standard form. Don't switch it. Don't switch the roles of the x and the y. This is the standard form for the equation of the circle with center hk and radius r. Your goal, if you're looking for the equation, is somehow find h and k and find r. Technically, you're looking for r squared. So let's try some examples. Find the center and radius and graph of each circle. Now notice we're doing the graph. The graph is going to be fun. If you try to plot this equation by hand, you're going to go nuts. You just have to recognize that you have a circle. How do you know you have a circle? You have an x squared and a y squared, and the coefficients of both x and y are the same. That's a circle. So center, radius, and graph. So it's actually a three-part question. On homework would be there 3 points. 1 point for center, 1 point for radius, 1 point for graph. Same thing on a test. So let's see, here's my equation. X minus 5 squared plus y plus 3 squared equals 9. Okay, notice it is in standard form. So you compare this to x minus 8 squared plus y minus k squared. Notice it's x minus y minus. This one is an x minus. That's a plus. Remember, minus minus gives you plus. And remember, 9 is r squared. So the h is 5, the k is negative 3. Okay? Because remember, minus minus gives plus. So hk is 5, negative 3. There's the center. R squared is 9. Remember, that's r squared. So r would be 3. Okay, now, if you're drawing this by hand, you'd actually plot your point 5, negative 3, and then move up and down 3 units. Kind of get your north and south pole, and then you can move left and right 3 units to get your east and west poles, and then as best you can, freehand draw the circle. Now, of course, I have the luxury of some software, and so 5, negative 3, radius of 3, and there's my graph. And yes, I drew it freehand. Again, here's my point 5, negative 3, go up 3 units, 1, 2, 3, go down 3 units, 1, 2, 3, then go left and right, 1, 2, 3, 1, 2, 3, and then just draw the circle. Okay, now again, in my math lab, you would actually pick the little icon that says circle, and you would kind of plot your radius, you'd plot your center, and then move out your radius and click, and then there would be the circle drawn for you. Here's my next one. I have x plus 4 squared plus y minus 2 squared equals 10. Okay, remember, this is x minus 8 squared plus y minus k squared equals r squared. So the plus says I've got a minus minus. So my center is negative 4, 2. My radius, remember, that's r squared. So my radius is going to be square root of 10. Now, because we're going to graph it by hand, it's about 3.16. Now, I'm not literally going to graph it by hand, right? So if I were graphing it by hand, I'd point my point negative 4, 2. My radius is about 3.2, then move up and down and left and right. So there's my graph. Okay, let's see if we can find some equations of circles. Now remember, somehow, some way, we have to get the center and the radius. So find an equation of the circle that satisfies the stated conditions. Now again, we want the standard form. So here's our first one. The center is 4, negative 2, and the radius is 7. This gives us everything we need. Remember, we need the center, we need the radius. So my hk is 4, negative 2. My r is 7. Remember, it's x minus h squared plus y minus k squared equals r squared. Don't put minus minus. Remember, minus minus is plus. And please don't put 7 squared. 7 squared is 49. Do the math. Don't square this out. Don't square this out. Remember, standard form doesn't square it out. And also, it's extra work. I mean, why would you want to do that? So somehow, some way, we've got to get center and radius. Number 2. It has 5, negative 7, and 3, 1 as endpoints of a diameter. So I've got the endpoints of a diameter. I need hk and the radius. Technically, the radius squared. So let's first find the center hk. Remember, I've got the endpoints of a diameter. The middle of that diameter is the center, midpoint formula. So because A and B are endpoints of a diameter, the midpoint of the line segment joining them is going to be the center. So hk is going to be 5 plus 3 over 2, negative 7 plus 1 over 2, remember. Add the x's, divide by 2, add the y's, divide by 2. That gives me, what, 8 over 2, negative 6 over 2. The point is what, 4, negative 3? There's my hk. Okay, there's my hk. There are actually 3 different ways you could go about finding r or r squared. Since I know the center, and these points are actually on the circle, I could take the distance between, these points are on the circle, I can take the distance between the center and A, or the center and B. That would be a radius. I could also, since this is a diameter, I could find its length and divide by 2, and that would be a radius. Okay, that dividing by 2 kind of scares me. So what I'm going to do is I'm going to use the center and either A or B, whichever one looks easiest. To me, B looks easiest. So I'm going to find R, or really R squared. Remember, the equation has R squared. So I'm going to use the center for -3 that we just found, and either A or B to find R. I'm going to use B, because B looks better. The numbers are smaller, and there are no minuses. I've already got enough minuses in the center. So since B has smaller numbers, I have chosen to use the center B. The center and B. So HK is 4, -3, B is 3, 1. Remember, the distance between them, that's the radius. So R is going to be the square root of, okay, the difference in the x's, 4 minus 3 squared, difference in the y's, squared, so -3 minus 1. So that's 1 squared plus -4 squared. That's 1 plus 16 gets rid of 17. Now don't worry about the fact that it's an awful square root, because remember, the equation uses R squared. So R squared is 17. Okay, here's our HK. So if I look at my x minus h squared plus y minus k squared, no, minus will be plus. So there's my circle. X minus 4 squared plus y plus 3 squared equals 17. Number 2. It has center -5, 2 and passes through the point 1, -4. I've got my HK. All I need is my R, or technically R squared. So HK is -5, 2. So we have to find R, or R squared. Okay, now before we looked at the distance between the center and a point on the circle to get the radius. This is going to be another way to do it. So writing what we know into the standard form for the equation circle gives us this. X plus 5 squared plus y minus 2 squared is equal to R squared, right? X minus h, y minus k. Remember, this point is on the circle. 1, -4 is on the circle. So plug it into the circle's equation, and you're going to get R squared. Notice I could have done that with number 2, in example number 2. So whichever way you like to get the R squared. So plug 1, -4 into this equation. X is 1, y is -4. So I got 1 plus 5 squared plus -4 minus 2 squared equals R squared. So it's 6 squared plus -6 squared. Okay, it's just a weird coincidence. 36 plus 36. So I get 72 is equal to R squared. So there's my R squared. Here's my HK. Let's piece it all together. I'm going to have x plus 5 squared plus y minus 2 squared equals 72. Okay, now again, we could have done like we did in number 2, or example number 2, find the distance between these two guys, and that's R, and then square it. And I could have done this exact same thing in example number 2 instead of the way I did it there. Okay, whichever way seems easiest to you. Frankly, to me, this seems easier. Okay, but you know, it's just a matter of opinion. Let's try one more circle equation problem. It has center -5, 3 and is tangent to the y-axis. So I've got my HK. Okay, got the HK. So tangent to the y-axis means the circle just touches the y-axis at a single point. Just like if you were tangent to the x-axis, you would be touching the x-axis at a single point. So the picture is this. Okay, there's my center, -5, 3. There's the radius. Notice you can just count 1, 2, 3, 4, 5. It's the absolute value of the x-coordinate. Remember, the x-coordinate tells you how far away you are from the y-axis. So the absolute value of the x-coordinate is R. If you were tangent to the x-axis, it would be the absolute value of the y-coordinate. So it's kind of like the absolute value of the other coordinate. So the radius is between the y-axis and the center, -5, 3, which is going to be absolute value of 5. Again, it's the absolute value of the other coordinate. So absolute value of -5 is 5. Notice, even if you didn't do the absolute value, when you square it, it's going to be positive. Remember, the equation uses R squared. So there's my HK, there's my R. So I'm going to have x plus 5 squared plus y minus 3 squared equals 25. Again, please don't forget to square the 5. Don't write 5 squared. Do the math. And again, don't square that out. You're looking for standard form. Standard form is x minus h squared plus y minus k squared equals R squared. And of course, you will simplify it. No minus minus. Remember, minus minus is plus. That is the end of section 1.1.